All right. I had a little circuit here that I built a number of years ago, and it it's basically a continuity checker and a couple of other things. Figure out where to put this thing. But yeah, here's the circuit. Um, at its heart, is a 4046 PLL chip that's being used, for its VCO. So, and here's one of the continuity probes for it. But I also piggybacked a couple of other things on top of it, including another continuity checker for experimental purposes. And I also built an attempt at a little metronome, but that thing doesn't work too well. I screwed something up in the schematic that, that's basically what it does when I activate it. But I don't really have, I can't make it, um, I can't make the length of its tone uh, short enough to make it metronome-like. So, wow, this sucks. Ugh, piece of crap. That's one of the reasons I abandoned the circuit, because I couldn't shut that fucking thing up. So, there was no way I could turn it off, but, I ended up, kind of running a switch, to the base of this transistor here, the 3904, to ground, so I can actually, kill it. I had to put a diode in there too, across that transistor, which you can kind of see there. Try to focus the camera for you, but yeah, you can kind of see the little diode right there that I had to kind of solder onto the, the emitter, to up the voltage so the 555 wouldn't just continuously kind of trigger it, because it would never quite shut it off. So that was annoying. So I ended up having to do that. Not surprisingly, honestly. But again, this thing was kind of thrown together for experimental purposes, but also the possibility of it being used for a test bench. Because I could sure as hell use independent continuity checkers. I hate, I usually have my multimeter or a bench meter or whatever tied up, doing voltage measurements and shit like that. Well, if I needed to measure a resistor or something like that, I mean, it'd be good to have just a separate ohmmeter, honestly, let alone certainly a continuity checker at the very least. So, this circuit, by the way, I found out on the internet a long time ago, from a really old article apparently, dating back to 1992. And this is it in its essence. I made some modifications because there was no input protection or anything of any kind on that. But even as it stands, it's got its limits. Now, let's see what else is in here. Oh, here's the rest of the article. I do not know where the hell I got this article, but but this is the reference to it. Maybe you can, Google it somehow, because I'm not even sure what the source of it is. Um, oh, this is another little one, but I didn't build this one. It was intriguing. I think I did try to build it, it seems like, but it didn't work as a separate little thing. I think I tried to actually breadboard it, maybe. But yeah, the thing just didn't quite work right, if I recall correctly. Um, but this is the article. It's very interesting how it works. Basically, when you don't have a voltage on it, right, it's essentially applying the full 9 volts input, to its sense terminal, right? So that means its VCO, and that's its VCO input, is actually at 9 volts. Okay, well, that makes the frequency, it's a voltage controlled oscillator, in this case directly proportional to the voltage. So the higher the voltage, the higher the frequency, right? So, but it's set up to where when it's in that condition, the frequency is so high you can't hear it. So, but when you go like short it across a resistance of some low enough value, well, that brings that frequency down, down, and down until it gets audible. But as a result, you basically have a tone that is proportional to the resistance. You get the lowest tone with a dead short circuit, right? That'll produce the lowest frequency. But as the resistance increases, um, you know, by a certain amount, let's say, 100 ohms or 1,000 ohms, the tone rises. So, it's an audible continuity checker that has a variable tone to it. So you can actually tell if you're probing around a circuit, if things sound right, basically. You can develop a feel for recognizing certain tones and associating it with certain resistances without having to get out of continuity, an actual ohmmeter or whatever and check the circuit. So it's, always thought that was kind of a clever idea. And, and the circuit does basically work. So, as you'll see here in a few minutes, but these are some modifications I made. I tried to put, at least some kind of protection on it so that, if the voltage is too high, we got, with respect to ground, it'll, short to the supply rails, although I don't think I used BAT 85 diodes on this. Let me look. Yeah, I think I just used probably small signal diodes from the looks of it. I got a rectifier in there. See, that rectifier, prevents, obviously reverse voltage from feeding back into it. So, if you got too high of a voltage, higher than its 8 volts or whatnot, that'll help block it. And this is just like extra protection that was probably, somewhat unnecessary. Because really, I mean, the only way it can actually supply a current that way is through this, but it's not supposed to supply current out of this terminal. Well, it is. I mean, basically, see this 1K resistor pulls us up to 9 volts, which I modified a 7808 regulator with a small signal diode to get it up to like 8.6 or 8.7 volts, close enough. So anyway, current will flow through this circuit, when there's no, load connected to it, basically, it'll be at 9 volts, frequency will be inaudible, at least on most ranges, because I actually do have all this crap adjustable. But at any rate, it'll flow through here, when you do connect a load, and which will, just like I said, lower the frequency. But at least, if you connect it to something with voltage in it, that'll help protect your circuit a little bit. The one thing that sucks about this circuit, though, is that, oh, and by the way, I got a, a 386 audio amp, hooked to a speaker here, and it, I don't know if I still have that LED, and I guess I do. Actually, let me look at that. Well, yeah, it doesn't really do anything. It's an AC signal. I mean, that's probably one of the brightest ideas right there. Again, I made a lot of little fucking mistakes on this. I didn't, spend as much time as I should have putting it, designing it. But because it was all kind of a mystery anyway, back then, 3 years ago. But anyway, this, controls the volume directly to it, and so, but that shares the audio tone, and let's, I've got my Decade box, and the thing's actually on right now, but you can't hear it. So, so let's explore this thing for a second here. Like I said, just the focus. Okay, let's see. I think that's the range setting potentiometer on the for the VCO, and I can't remember which one of these it is. Let's see. 'Cause I believe this one is probably our volume control, and I think this one is the range setting, but we'll find that out here in a second for sure. But see, right now I've got it hooked up to my resistor decade box, and I got it set to like 1 mega ohm, so that's, you know, pretty close to being an open circuit, right? But let me go ahead and reduce it from that. Okay, you know, that's quite audible, and that's at 0 ohms practically, you know, 0.1 ohms really. So but let me up it by 4 ohms. Alright, so you can hear the difference, right? Add another 3 ohms to it. Let's go 30 ohms, 40 ohms, 10 ohms, 100 ohms, 200 ohms, 400 ohms, 1K, something like 2K, 3K, 4K, 10K. That's barely audible. I can just barely hear that. And then of course I go to 100K, can't hear it at all. Even 40K, I can't hear that at all. So, you know, but like I said, the thing is range adjustable. So, you know, if I start adjusting that all the way to the left, well, I can still hear it even at, you know, 40K, even at 100K, even at 1 meg. So that's what I'm saying, you know, I've gone too far in the adjustment, so that's like too sensitive at that point. So let me tune it back down a little bit. In fact, let me tune it all the way to the other side. Alright, so now let's turn all the resistance off, if it isn't already. Oh, there we go. Okay, so now, you know, that's all the resistance off. That's what 10 ohms sounds like, 100 ohms, 1K. See, 1K is now inaudible. You know, it was very audible before. 400 ohms, 700 ohms is inaudible. So, 500 ohms, barely. 600 ohms, I really can hardly hear anything, just barely. It's a great way to test your hearing. So, but at any rate, yeah, the thing basically does work. But what I was going to say, the problem, you know, one of the problems is let me get my little meter out here. Okay, so I got my little DMM over there. I'm going to hook it up to this. I'm not sure which polarity is which. Let me. Oh, got it backwards. Ah, damn it. Fucker. Okay. Alright. So we're getting 3.7 volts right now at, you know, 1K, right? If I take it down to nothing, you know, it's only 0.9 volts, or shit, you know, very small fraction. Even at 4 ohms, we're putting out 28 millivolts. Now what happens when I put it up to 10K? Okay, we got 6 volts, alright? You know, at 100K, in addition to that, it's at 8 volts. You don't want that on your circuit if you're probing an active circuit, and that's kind of the problem with this thing, and I kind of recognized that when I was doing the design. You know, I was like, man, that is such a neat idea. Although I will say one of the other problems I have with it is this. You know, hear that? That's me just trying to make direct contact. It's a squirrely signal. You know, it'll probably work better with actual probes, but you know, that kind of squeal I sort of dislike. You know, that's not what you want to hear out of your continuity checker. It just, you know, seems uncertain, right? You know, in fact, let's lower it. You know, because like I said, you know, putting like 100 ohms, right? That's what it's like with 100 ohms. You know, I don't think I'd like the sound of that. Here, let me attach it to my meter probe. You know, that's better, but it's still a little squealy, you know what I mean? But it's not bad. I mean, it's probably kind of usable if I went and put actual probes on it instead of these orange wires. But you know, it's a neat idea. From a circuit standpoint, because that's why you would want to use something like this. I'm not going to sort through my resistor drawer with this thing, trying to determine what, value of resistance I need, right? I mean, this is something you want to probe an actual circuit with a bunch of components in it and stuff, and get a feel for, does it sound right? Because you could definitely train yourself, to say, oh, that sounds like a 10K resistor, or that sounds like a 100 ohm resistor, or that's a, pretty much a dead short. It could be quite useful for probing around a circuit and see if something sounds funny. Versus if you're looking at a schematic, and you're saying, hey, I shouldn't be hearing this tone. I think this resistor, is gone bad or something like that. It's either too low, too loud of a tone, too low pitch, for 1,000 ohm resistor shouldn't sound, 1,000 ohm resistor, should sound like, well, let me tune it. Okay, so I mean, 1,000 ohm resistor should sound like this, right? Not like that. This is at 4 ohms. So that's the difference between 0 and 4 ohms. So it should sound like, not like that. It should sound like that. So you've got a bad resistor there if you're hearing that. You got a bad resistor, or it could be the other way. You're expecting it to sound really low, but for some reason the resistor's got fucking charred or something, or there's something else going on in your circuit, some other resistance you're not expecting. Maybe some other component went bad, like a capacitor went short circuit. You could actually hear that too, if a capacitor, went short circuit on you. And you're saying, well, this has a, 10K resistor, I shouldn't be hearing anything. Well, no, you're hearing something. Okay, well, all the resistors seem okay. There's something in here, fucking up. Anyway, it's a potentially useful circuit. The problem is that voltage. And, that can, still put in, out about 7 or 8 milliamps, through this 1K impedance, out through your probes. So again, it probably might not damage anything, but it'll certainly activate transistors and logic gates, and if you have 5-volt logic on it, it'll probably damage it. So there's a good chance of that. That's way too much current for way too much, BS. And again, I did the best I could, but it was a neat idea, and I wanted to actually test it outright. But because I knew what the limitations were, and let me look this over real quick so I can inform you of any modifications of this schematic. I told you about the transistor here, and that's coming from the 555, because basically I have it so the 555, sends its square wave out, with that annoying metronome, and when it's low, it's supposed to turn this transistor off, right? That's why I had to put the extra diode, because it isn't quite low enough. So, but when it goes on, it turns on this transistor, and you can adjust what kind of voltage level it applies with this little potentiometer, which is somewhere on the board here. I don't remember which one it is. It's yeah, I don't know. It's over by this transistor. I think it's this one. But I'm happy where it's at. But yeah, that's, that basically uses the same VCO, okay, to actually activate it, so the signal goes, it pulls a load. It's a 500 ohm pot, it's set up as a rheostat, and it'll pull a load, with 1K resistor, pulling the voltage from being 8 volts down to, for example, even close to 0 volts, if you set it all the way, it'd be, 0.5 volts, 0.3 volts, something like that, making a higher pitched tone. So, but otherwise it's so high frequency you don't hear it. So that's how it works. I'm using the same circuitry. I'm getting, really triple functions out of this, and using the same audio amplifier. You can see that feeds from the F out terminal of our VCO on the 4046. So, it's exclusively what drives this, which makes it challenging for some of this stuff sometimes, because when you make changes to one thing, it kind of changes the other functions to some extent. But at any rate, that's a separate little issue. And again, I fucked up on this circuit somehow. I can't get that damn tone. You know, I mean, I did something wrong on this. I'm just not sure what. Because I can't get that beat, you know, to be any shorter in about a second or so. And I did, you know, I changed this 1 microfarad out with 100 nanofarad. Still sounds the same. I used my resistance decade box to kind of short across this, you know, and with various resistances, you know, can't really get it to do much. So it with a 1 microfarad cap, though, it did make a longer tone, adjustably longer. But you know, with this, it doesn't work. So I mean, I definitely screwed something up on that. You know, I'm not really sure. Again, I didn't give it its proper due, I guess, when I was wherever I got that that thing, that circuit design. I might have gotten that out of a data book or something, but I probably fucked up somewhere. But at any rate, because of the voltage problem, I said to myself, well, why not let me try an experiment and see if I can make a very low voltage continuity checker. So basically, I took this TLO72 op amp, and now in practice, I got rid of this resistor and this diode thing here, and I really just connected the output of this op amp down here directly to our feedback of this inverting amplifier. So you can see that, you know, that shit was supposed to go right there, but I just shorted across it so that the output of that op amp is going directly to the inverting network, you know, of that other amplifier. So because you know, I never even soldered components to that, so I never actually built it this way, but I just modified that right off the bat. Because I think I realized that it really wasn't going to work right if I did it that way, or at least wouldn't make any difference. But anyway, you know, this op amp here, I'm just, you know, I've got a voltage divider in its input. It's a unity gain, so I'm just using it as a, you know, as a low impedance, you know, voltage reference, because this is a single supply op amp. You know, it's only supplied off 12 volts. You know, and its regulator puts out just under 9 volts. So this is about 4.5 volts output. You know, so that's the reference, you know, for this inverting amplifier here. You know, all the stuff is DC coupled because we're working with DC, but still it's a single supply is how I'm using the op amp. But at any rate, we got this 100K resistor, you know, basically, you know, going through this BAT 85, which is really just a, I just used a, 4148 small signal diode on this one. I didn't want to waste BAT 85s, I guess. But at any rate, I have that, and that'll drop, you know, a voltage drop across it and goes down and sinks it into the output of the op amp, right? You know, all well and good. So what happens is, basically, this is a, you know, an inverting amplifier, you know, that can give you between, you know, a gain of about maybe 2 to 51 or so. You know, it's a 50K potentiometer, or rheostat, you know, wired as a rheostat with a 1K, you know, feedback, well, 50K feedback resistor and plus your reference resistor here. So, I mean, you know, that gives you your gain. So basically what happens is that when there's no load on these terminals, the voltage is at its maximum output, you know, which is not very high, unfortunately, because it can't go up to the supply rail, you know, so it's probably 1.5 volts or more below that, maybe even a couple of volts. So, you know, that's makes it difficult to get the frequency, you know, to be as good as you'd like, because I can't drive it up to the supply rail like, you know, like the VCO works. Because, you know, when this is here, it kind of overrides this 1K resistor quite a bit. It takes over the supply rail, you know, a bit, you know, in terms of impedance. So, because it's much lower impedance than this 1K resistor. So, you know, so that'll, you know, that'll kind of do its thing, but still it makes the frequency high enough to where it works. And I guess I can go ahead and connect it up, because, you know, they can be connected up at the same time. So So there's that. Okay. You know, now, you know, you see that when I make changes on this, you know, you can see it in that little bar graph thing that I built there, which was kind of ill thought out. But here are the terminals to it, you know, these green wires. So, you know, you can kind of hear it, but look at our voltage out there. It's only at 6.5 volts unloaded. And again, when I didn't have that thing connected, you know, it was, I guess, at 6.8 volts. So there's not much of a difference right now. So, you know, oh, okay, yeah, there we go. So basically, yeah, I upped it another 100K. I didn't. So, you know, even at that level, it's pretty inaudible, even with just 10K of resistance in it. You know, it's pretty inaudible where I have it adjusted right now. But, you know, so if I, you know, up it to, you know, add another mega ohm, okay, that's where we're at. But then let me connect this up. Okay, so that brings it down to 6.9 volts. So that's as much as that, you know, since I basically, you know, open circuited this in effect, you know, these orange terminals, you know, connecting that sucker up, you know, is only, it only get up to about 7 volts how it is. Now I have adjusted its gain, which is set by this potentiometer here, which it's this one here, of course. But, you know, this is the best point I found that it, you know, the most comfortable point it works with. But still, it's fairly inaudible at that point. And like I said, when I, you know, tie these leads together, you can hear it's a high-pitched sound, though. You can't get it any lower because this thing will never drop below. In fact, let me show you what it does. 4.89 volts is about as low as it'll drop to. So, and that's again because it's a single supply op amp, and I can't get it to drop. It's one of the follies of using a single supply op amp on a circuit like this, you know, is that it kind of limits you. But again, it was for experimental purposes. But the thing works. In fact, it not only works. Let me disconnect this one and attach it to this, or resistor decade box. Okay, I still have it set to 1 mega ohm. But, okay, so that's it. You know, that's at 20 ohms, 30 ohms, 100 ohms, 1K, 2-ish K, 3K. By 3K, you can't hear it anymore. So it does the same sort of thing. I mean, it does work the same way as the big one. But, you know, like I said, you know, you can see it this level, you know, we got, you know, this is actually, at this point, since I got these terminals connected to our decade box, I'm measuring the output voltage across that. Let me reverse the terminals so that it's positive. Okay, so, you know, I'm sitting here, you know, let me set it, turn up to 1 meg. Okay, 1 meg of resistance, we got 125 millivolts. That's the maximum voltage this circuit will impress across any circuit you connect it to. No more, no less, and that's with, you know, 4 meg, okay, no difference. It's only when you drop below 4 meg, and as you do, the voltage drops. Okay, so if I drop it to 0, you know, it's audible, you know, and it's dropping 5 millivolts across it. So, and now we're down to 7 microvolts, and now so low my meter can't figure it out. I guess I could turn it on the microvolts range or something, but, you know, that's good enough. You know, you get the idea. And like I said, you know, at 1K, a little over 1K, it's 39 millivolts, you know, and at, you know, 10K, it's, you know, 100 millivolts. So, and the thing is, remember, this is, you know, the center reference is a roughly 4.5 volts, and I got 100K feeding into it. Then you got a voltage drop, you know, and the voltage drop across that diode is obviously really small. That's what we're seeing. That's a voltage drop across that diode. And but it's got, like, you know, if you do the math, it's like, you know, 45 microamps, you know, is flowing through it. So under short circuit conditions, it'll not put any more than 45 microamps through your circuit. yet it produces a usable audio tone. And it's got, 500 ohms of input resistance. I put two in parallel so I can get 1 watt of protection out of it. But that means, 1 watt, if I put this across a live terminal, if you had, um, again, a better diode might have made sense. With a small signal diode, I don't know that I could have gotten too much out of it. But if we put like 25 volts across it, let's say we forgot to turn the power off of what we were measuring. Well, we got, basically roughly, 50 milliamps flowing through that thing, and that's it. That's it. And even a small signal diode can handle that. In fact, if we put accidentally 50 volts across it, you're going to get 100 milliamps. And again, even a small signal diode could probably handle that. But this acts like a forward voltage protection scheme. And of course, obviously, if you connect your terminals in reverse and there was a voltage 50 volts this way and, 0 volts here, it would flow in reverse. But this could handle up to an amp, and, so, I mean, it's pretty damn good circuit protection with pretty damn good, output voltage. It's not going to burden your circuit. You sure as hell won't turn any transistors on with 120 millivolts. You're certainly not going to damage any logic gates or anything like that. And it still works with the same principle. It's just not well implemented, but it still works. And, and plus couple that with a low current protection. I mean, yeah, you could use this thing on about anything. And like I said, and I do have this little LED bar graph thing, which is, which works. It just doesn't work up to full range because the voltage doesn't go up high enough for how I set it. But that's what I'm saying. That little thing does work too. Say the more of a, it just doesn't go full scale, but it will respond too to our other one, because our other probe is still active too, so they can both work at the same time. In fact, you can have that goddamn metronome on at the same time. Let's hear that again. We'll love that. So anyway, yeah, it sounds pretty fucked up, but basically all three of these use the same VCO, and they modify it, in a proportional way, so they can all three run at the same time. So let me turn this damn thing off. Okay, but yeah, they all three run at the same time. So I'll turn that back off. But I mean, it's a good circuit, but again, I kind of gave up on it mostly because I couldn't shut that stupid metronome off. In fact, I had to rewire it today, but still, yeah, I don't know. I don't like that thing, but I do like this front end circuit, and you could actually do something like this with an Arduino. You could actually take, this same exact circuit and feed it into an Arduino now with reduced voltage and all that crap, of course. In fact, using one of those rail-to-rail 5-volt op amps would be perfect for this because it is just single supply. But you could duplicate this same input circuit with it and then have it feed into the Arduino, where 2.5 volts is its, center voltage, right? But so, with the gain on it and everything, if you see the voltage, at like, 4 over 4 volts, for example, that the circuit's open, right? But then, when you close the contacts, that voltage will drop down towards the center. Then there's continuity, right? So yeah, you could have the Arduino, actually pay attention to that with its ADC, and and again, you could even do something better with the amplifiers too. Maybe give more gain or whatever you like. But the point is that you can make the Arduino signal, generate an audio tone that's proportional to its measured signal. And the great thing about the Arduino is that you can actually make adjustments to it. So if you attach a little, like 1602 display to it, with a little rotary encoder, or whatever, little navigation keys of some kind, you could actually set, have menu settings for, okay, 50 ohms. I don't want to hear anything, if this thing detects it above 50 ohms or something like that. But to get around some of that squirreliness, though, I might be inclined to say, well, if it does detect a signal above a certain level, even if it's unsteady, to at least put out a tone just briefly and allow it to settle, before it actually tries to interpret the frequency. So I'll make like beep, beep, or beep, something like that, you know what I mean? So, but just for a brief second, that tells you it's got continuity, but then wait for a settling time to hear the actual resistance. So you could do something like that, but you could definitely have pre-programmed values, of what you consider continuity, and you could even just have it work like a regular continuity checker if you were annoyed by the variable frequency thing. So there's a lot of things you could do if you took a circuit like this and hooked it up to an Arduino with a little bit of, elbow grease there. So I'm actually pretty excited to do that, because that's pretty much the conclusion I came to when I looked at this circuit, because I actually tried this out, 2.5 years ago, something like that, and was kind of disappointed with it. I mean, sure, it worked, and it was neat, seeing this part of it, but, my circuit, with the audio tone being so high and everything, was not as useful as I'd like, but I honestly didn't, bother checking some of the other parameters just because of the annoyance factor of that damn thing beeping on me. So I just kind of set it aside and said, well, I think I can do something like this with an Arduino, and then I can actually tailor it, to the frequency, audio range I want, so I can, here I'm still a victim of this VCO, right? So, but I might want it to always, make a very low tone, no matter what my setting, no matter what my resistance range is, because, by adjusting that knob, like I said, you kind of adjust your resistance range, like I demonstrated. But so I can make it so that it always sounds the same at low, full continuity, because otherwise I can't do that. And at some point, it'll always be on like that. It's always on. No matter what, I got it set to well over 1 mega ohm. It's still always on, so it's got to, I can't get the full range. That's nearly all the way counterclockwise, but right about here is where it starts to, get to be where I want it to be. But let's see, turning. Oh, I guess I don't have this connected to that anymore, do I? Yeah, okay. Okay, so that's 100K, and that's its short circuit setting. So, I can adjust it all the way clockwise, and that's what we got. And okay, that's great. But now 1K turns it off. But I'd still rather the short circuit sound the same as it did down here, because that's lower frequency. That suggests, I say I can't go that low because I can still hear it. Now I got to tune that down. So that's about the best I can do is this tone, which is not half bad, and let me use the volume control here. So I did build that in, thank God. That's the only reason I could tolerate that metronome thing at all. But yeah, I can, make adjustments to it, because like I said, when I have it set at that range, that makes it so I can just barely hear it at 10K. All right. In fact, let me turn it up. Yeah, I mean, I can just barely hear it at 10K. That's like at 8K or something like that. So again, that's clearly audible. But if I wanted it lower range, okay, I had to turn it all the way that way. Okay, so that's the lowest tone I can get, but I can clearly hear a difference between just adding 4 ohms into it, let alone 100 ohms or 400 ohms, but 1,000 ohms, it's set. But I can make it sound the same with an Arduino, no matter what, by just controlling the proportionality or whatever, if I wanted to do that. you know, so I can kind of get used to it a little bit, you know. Anyway, the point is, with an Arduino, there's just a lot of interesting things you could do with a continuity checker. And in fact, you know, to some extent, you might even be able to build a little ohmmeter into it if you got a display hook to it and everything. You know, it's not entirely out of the question. So anyway, that's why I wanted to document this video, because I do intend to come back to this. I'm going to go ahead and sock it away instead of throwing it in my junk box like I just about did before I decided to make this video. Because the concept, basically, I think is still a worthwhile little project, because I'd still like to have, you know, at least one thing lying around that's just a continuity checker. And again, if I can get a little resistance meter out of it too, that's just low range, you know, that would be great as well for certain applications. So, but you know, with an Arduino, you can have the ability to turn the noise on and off. Certainly, you can have it control an LED, so you can have visual continuity checking, and even like a little bar graph, like I was trying to do. You know, that's a nice and bright indication of continuity checking. So you can, you know, do a better job than I did on this. But at any rate, it's a neat little gizmo, and it's got, you know, some potential. So I just thought I'd make you aware of that. So cheers.